Take a network break. We're launching a new line of probiotic virtual donuts to improve gut health, especially for our U.S. listeners who may have overdone it during the Thanksgiving holiday. Today's show's got a lot of Nvidia stories, some space networking, and the successful nuptials of Broadcom and VMware. We're sponsored today by Do It. Reduce your cloud spending by improving your cloud efficiency with Do It, an award-winning strategic partner of Google Cloud and AWS. Find out more at doit.com. That's DOIT. doit.com. And stay tuned after the news. We're going to have a Tech Bites with Nokia. We'll be talking about distributed denial of service attacks. Attackers are finding new ways to take advantage of higher levels of bandwidth and the ever-growing number of network-connected devices. We're going to talk with Nokia about what's brewing on the DDoS front and how Nokia's Deep Field is bringing new analytics techniques to the fight.
Interesting. Yes. Interesting stuff going. Like, it's Nokia's approach to this is to put it inside the router. And they actually have their own DDoS service, which they acquired a few years ago. So interesting to listen to and think about how this approach is different to how other people do it.
Yep, for sure. And last but not least, check out our Slack channel. It's a growing community of networking and IT nerds asking and answering questions, swapping tips, and generally hanging out. You've also got our weekly Human Infrastructure newsletter. It brings you the best of the technical web, plus links to useful resources and DAG quality memes. And check out our weekly Human Infrastructure newsletter. It brings you the best of the technical web, plus links to useful resources and dad joke quality memes. You can find it all at packetpushers.net. All right, let's dive into the news. It's been a long time coming, but Broadcom has officially closed its $69 billion acquisition of VMware. The announcement came the day before the U.S. Thanksgiving holiday. In a blog, Broadcom CEO Hock Tan said the company will commit to, quote, invest significantly each year to advance VMware's innovation and customer value, end quote. Half of that promised investment's going to go to R&D, and the other half will go towards enhancing VMware's engagements with resellers and partners.
Yeah, so it's been 7 finance years, Drew. Or as we would call it in the real world, 7 quarters.
It must have seemed like years, I'm sure, to some people inside VMware.
Yeah, that's right. So it's it's something like that. So next time we talk about a mega acquisition, don't think it's going to happen next week. Like we said, it takes a couple of years for these things to go through. And there may be some burdens on Broadcom, just to sort of focus on the negatives. China did put a bunch of conditions, and so did many of the other regulations put a bunch of conditions on Broadcom around the acquisition to do with anti-competitive practices. In general, we don't know. We know some of those and some we don't. So who knows what impact that will have on Broadcom down the stream. But it is interesting that the blog post, there's a link in the show notes over on and you go get that from the website. He did call out that he's going to focus on VMware's cloud foundation. Now, that's not surprising to me. The idea there is that they want to build private clouds on premises. And that's not new, but that problem still isn't solved. VMware's been trying to put together its on-premise cloud for well over 15 years. And I guess it's fair to say it really hasn't stuck, Drew. I don't think customers are really happy with vCloud and then VMware Cloud Foundation and all of its iterations. It doesn't seem to have been unified and bundled up correctly.
I mean, yeah, we haven't seen a lot of actual development of private clouds in the sense of when they were originally sort of touted, like, you've got a service catalog that folks can just press a button from and get those resources spun up. That hasn't really happened. I think Cloud Foundation is also VMware's way to make sure it's not lost in the public cloud market. You can use VMware in the public cloud and Cloud Foundation. I think one of the value props is that you can manage and monitor both your private and public clouds, or do a multi-cloud integration, a hybrid cloud integration, if that's what you want. So it is definitely, I think, an on-prem and a cloud play, and makes perfect sense to me that that's where VMware would want to invest given the way things are going.
Yeah, but what it does mean is what happens to the other things. But before we get to that, let's talk about the other thing that Hock Tan was willing to talk about was application networking and security. So I think here what you're seeing is that cybersecurity is a huge growth market right now. VMware was sold for $68 billion to Broadcom. You've got companies like Palo Alto Networks that are worth $75 billion today, right? So cybersecurity is much more valuable than simple VMware's, low value business. If you want to put it in that sort of course, that's unreasonable, but you get the point.
Yeah.
That financially, right. So, but what I also point out is that Broadcom has substantial existing security products. It's got Symantec, which it acquired a decade ago and has been iterating on. It's got an identity management solution, threat detection, and a bunch of other cybersecurity tools, which will overlap with VMware somewhat. Now, I wouldn't say that VMware has been able to get its cybersecurity chops or credentials out in front of the customers well enough. I mean, NSX with VMware combined with the SASE SD-WAN product that acquired from VelaCloud and its ability to reach into the branch and the campus really hasn't crystallized the way that I thought it would. And
Right.
most of what VeloCloud's been doing is attacking the managed service providers and trying to sell itself to telcos. It hasn't done a great job of convincing enterprises to compete with other players in the SASE market. And I wonder, does Broadcom double down here and say, we are enterprise, we're not service provider? I mean, they're not going to walk away from service provider, but do they say, like, we should be competing head to head with Cisco and Palo Alto and Fortinet with our SASE SD-WAN strategy? Do you think that's viable?
Yeah, I think it's very clear that in the note that Hock Tan put out, the blog specifically called out application networking and security and load balancers as essential elements in Cloud Foundation. So clearly, cloud is the focus. No mention of the company's SD-WAN or SASE portfolio. So I don't know if that's a signal, by its absence, that maybe it's not as important.
And thin client as well. VMware's got a thin client business.
Client.
Having said that, of course, VMware did announce a thin client hardware this week. AWS released its Workspaces thin client, which is based around the Fire Stick, and it's a thin client to attach to a new thin client service from AWS this week, Drew. So, any takers on a 2024 being the year of the thin client?
No,
Again?
No, I will not place that bet. Nope. If past performance is any indication of future results, I will say no.
History repeats itself, and history's never said that it's the year of 2024.
Right.
It's interesting also to note that VMware was once deemed unbuyable. I do remember about a decade ago that every time people talked about somebody like Cisco acquiring VMware or so forth and so on, it was always rejected because it was seen that if VMware was to work with one server maker, like to be acquired by HPE or by Dell or by Cisco, or one of them, that VMware wouldn't be of value. And then, of course, Dell did buy it out through its acquisition of EMC, which was a bit of a sleight of hand, really. But VMware survived. I think the era of co-opetition, where companies can cooperate on some things and compete on others, which makes it very confusing for customers, by the way. And I understand that. So it's going to be very difficult for them to sort of say that if he's going to change the direction of VMware, how does that work? Now, keep in mind that there is an alternative to VMware, and it's Nutanix. And the other alternative is that you go all in on the public cloud. I don't think there's room for any more private cloud. I think it'll always be Nutanix and VMware. Enterprises don't like too much diversity in their infrastructure. They really don't want dozens of suppliers and a wide range of choice. So I don't think I think VMware is going to be a good money source for Broadcom going forward.
So my big question about this acquisition is Broadcom's long-term strategy for VMware. Given their previous big acquisitions, I'm thinking CA Technologies and Symantec's enterprise security business. To my mind, they weren't designed to grow the company or to serve as platforms for Broadcom to sort of invest and rejuvenate these organizations to compete more vigorously in their respective markets. I think it was to diversify Broadcom's portfolio and provide a reliable revenue stream from entrenched customers. Is VMware in that category, or is VMware going to be a new direction for Broadcom where it is going to make significant investments in making VMware strong and competitive in the public cloud space? I think we'll find out if we see things like maybe VMware making some acquisitions. I'm thinking if they really want to compete in the hybrid multi-cloud space, maybe something like one of the multi-cloud networking startups, a Proximo, an Alkira, and an Aviatrix could be an indicator that Broadcom is really serious about helping VMware continue to grow.
Yeah, because I mean, VMware's NSX really didn't solve the multi-cloud networking issue.
No,
at all.
No.
And then, of course, Broadcom has made serious commitments to its shareholders that VMware will reach 60% gross profit margins and deliver, substantial increases in profitability to the bottom line within a year. So it's hard to imagine what sort of transformation is going to happen that couldn't have been done by VMware themselves that would produce that sort of increase in profits from $1 billion, $1.5 billion a year to $4 billion a year without something really radical happening. And certainly I'm getting mixed stories from people leaving VMware, not leaving VMware, people who you thought would leave are not leaving and all that.
Right.
But that's pretty normal.
Right.
But I do think VMware is going to hurt. I think there's a lot of people who've been at VMware for an extended period of time. So senior executives who've been there for 10 years and are probably sitting on, millions in share options. They'll be gapping out to take a new chance. They don't want to stay around. And, maybe they're not convinced that what Broadcom's going to do for VMware aligns with what they want. And so they're heading out. So it'd be interesting to see how many of those. But again, it's not very clear how that's worked out. VMware has been seeing people walk out the door in substantial volumes for the last 6 weeks leading up to the acquisition. So Broadcom hasn't been shy about ditching people, ahead of the acquisition.
Yeah. So a lot to still unpack, and I think we'll see what Broadcom's direction as the months go by. All right, moving on. Nvidia has announced a new category of 400 gig NIC. It's calling a SuperNIC, not to be confused with a smart NIC. Nvidia says this SuperNIC is purpose-built to support AI workloads on Ethernet networks. Essential features include high-speed packet reordering to ensure packets arrive and are processed in sequence, congestion control to avoid issues like latency, retransmissions, and programmability.
That sounds like, what was it? What was that thing we talked about? Ultra Ethernet, Drew. Does that not sound like that?
It does sound a little bit like also what the Ultra Ethernet Consortium is trying to bring about. Yes.
Yes. We talked a bit about the Ultra Ethernet Consortium, and part of their goal is to take switches and turn them into address the weaknesses of normal Ethernet networking,
right,
which of course means, frame drops happen, packet drops happen. And yes, we have all of these high-speed backbones, but a lot of transient issues are solved by just making the buffers too big. That doesn't work for AI networking when you're doing RDMA data transfer. So what Nvidia is doing is it's using a combination of the smart NICs, or the SuperNICs as they now call them. We'll talk about that in the next piece, but using DPUs to perform memory-to-memory transfers. So instead of moving data from the GPU to the CPU then runs it down a networking software stack and then sends it out of a dumb NIC or even a smart NIC. In this case, what happens is the GPU talks directly to the DPU, and any writes in the GPU memory then get replicated out to other GPUs in a cluster that are generating the AI processing. And that must happen at the shortest latency and without any packet drops at all for that to achieve, because all the GPUs have to be processed. Each step is calculated. All the GPUs have to lockstep. And if any packets get dropped, then the GPUs stop until such time as the data is coherent across all of the devices. And so one way to do that is RDMA, and Mellanox, which is now NVIDIA's Ethernet division or networking division, had a long history of working on this in its smart NICs and with its Mellanox switches and supporting the idea of a lossless Ethernet fabric from end to end. And, remember when we talked about Ultra Ethernet, I said, ultimately the game here is that DPUs can solve this, not switches. Switches can help. They can offer some features. And what NVIDIA is saying here is that combined with their Spectrum 4 switches, which is the next generation of 51 terabit per second high performance switches, they can look at the telemetry, see where the congestion points are, and then the DPUs can route around the weaknesses in the fabric. They don't need specialist features in the ASIC to do this. They can do it with what they have. And so this is interesting. Well, very interesting to think that this is already a solved problem. The networking vendors haven't even got it started yet, right? They're still just getting together, having tea and sort of working out, what could we do that would make us more money? And NVIDIA's already there saying, we've already got a working solution. It's 10 years old. It's proven. So, and more importantly, they're saying, and you need the DPUs. The DPUs and the switches have to cooperate to make this happen. And this was my point about the Ultra Ethernet Consortium, is they can talk about ASICs and switches and, doing stuff and signaling some sort of control plane that can signal congestion in an AI networking fabric. But at the end of the day, unless the DPUs are participating, pointless. So I think that there's going to be a reckoning here because the networking companies haven't started to make DPUs. I think companies like Cisco and Arista and Juniper need to be making DPUs to go with their switches, because that is where the network starts. And they should have done it 10 years ago when NSX came along, but they didn't. Cisco tried to with its VIC inside of its UCS servers, but it never really took off. They didn't do a great job of it. It wasn't all that stable, the hardware NIC and all that sort of thing. So for me to believe that they can suddenly come up with a DPU, the network adapter integrated with the networking fabric, is a little hard to believe. And I think NVIDIA might have a step here.
Well, NVIDIA is definitely trying to move the conversation away from let's modify Ethernet in the switch ASIC to make it more suitable for AI networking, and punting it out to the smart NIC, the DPU, the SuperNIC, whatever you want to call it, because that's where, they can play and whether they can make a difference. I think it's also interesting that NVIDIA now can talk to AI customers and say, you want InfiniBand? We got InfiniBand. You want Ethernet? We got Ethernet. We got our DPUs. We got our switches. We can do whatever you want. They also have the GPUs. They also have SDKs for app developers. They also have pre-built AI models. It's a classic Cisco move where they are going to build an entire stack, and you can buy everything from NVIDIA. So a very bold move.
Well, it's important because the DPUs are running RDMA. RDMA has to be called from the software API. Their software, uses RDMA to get the acceleration. So yeah, when they want to call it a SuperNIC, I'm kind of on board, Drew, right? I'm kind of on board.
You're going to go with
I
this?
don't like I think, if the NIC is doing more than just NIC, like a smart NIC is one thing, a DPU is it's not a great word. And I mean, and ultra Ethernet is a very contrived sort of term. So SuperNIC is a little bit more conventional, smart NIC, go one better, SuperNIC. I don't hate that. I don't hate that. Marketing's going to happen. It's going to be inflicted on us. So maybe that doesn't suck so bad. If it's a branding exercise, maybe it's not the worst one we've ever seen.
I will give you that. It's definitely not the worst one we've ever seen. I think we're going to have a lot more to talk about this whole thing because there's so much going on in this space, but we should move on. But we're going to stick with Nvidia and the SuperNIC announcement. Nvidia's announced that it's partnering with Dell Technologies, HPE, and Lenovo to add that SuperNIC to Dell, HPE, and Lenovo server hardware, and to sell complete stacks that also include Nvidia's Spectrum switches in the stack. Nvidia is offering Spectrum switches in the bundle, and these switches can run Sonic or the Cumulus Linux network OS, which Mellanox acquired before Nvidia acquired Mellanox.
Yeah, I know you get your choice of NOS. You can choose Sonic, Pure Sonic, as they called it.
Pure Sonic.
You can choose Cumulus Linux, which they acquired when Mellanox was acquired. Mellanox bought Cumulus just before they were acquired by Nvidia. And you can also run NetQ, which is Mellanox's operating system that it had from, before it acquired Cumulus and before Sonic was around. So you can actually have your choice of flavor of NOS. Maybe not all the choices, but you can have those choices for sure. Spectrum X is actually a product name that covers not just the Spectrum switches, but it also covers the Bluefield DPUs. Did you notice the story there? It's like the previous story. So what they're saying here is that NVIDIA will supply Spectrum X, which is the switches and the DPU bundle, to HPE, Lenovo, and Dell, and they'll be able to put that Spectrum X Ethernet networking into AI for their server lineup. So the idea is here that if you go and buy a couple of racks of Dell AI or HPE AI or as a GreenLake, you can optionally choose to have NVIDIA's switching solution in there. So there was a case here where they're talking about a supercomputer powered by Spectrum X. It uses Dell PowerEdge XE9680 servers powered by H100 8 GPU platforms, Bluefield 3 DPUs, and SuperNICs with Spectrum 4 switches. So the idea here is that if you're going to buy Dell servers because that makes you happy, rather than NVIDIA servers, and that might not make you happy, right? Then here you are, you can get them with NVIDIA GPUs and NVIDIA's networking so that you have a better chance of actually making this AI, work at a rate. You're not trying to integrate a third party. You're not trying to integrate Arista or HPE or Dell switches and then somebody else's DPUs and then, get all that working. That's not the way we're working at the moment. I think the way to go here is to get a bundle, and that's what NVIDIA is reaching for here.
Yeah, for sure. Just one note on the NetQ. I don't think that's a network OS. I think it is actually an analytics and telemetry platform that was originally developed by Cumulus. Sorry. Yeah, so just
you're
to
right.
Clarify that.
They do have their own in-house OS, but NetQ is actually sort of like an SDN overlay that you can use to orchestrate. Yeah. It's not an intent-based. It's more of a, let's say, a configuration automation tool, shall we say, and visibility tool.
Yeah, and telemetry, yeah. But again, I think that this general announcement ties back to that whole previous discussion we had where NVIDIA is looking to sell you bundles of all NVIDIA stuff, and they'll partner with Dell, HP, and Lenovo for the server side. And otherwise, it's an NVIDIA stack through and through.
I guess right now, I wouldn't want to be running an AI cluster over traditional networking from branded vendors because they got big buffers. They do have problems dropping packets at very high data rates. I mean, these servers are running at 400 gigabits per second, right?
Yep.
So, and you drop a frame in RDMA, your whole GPU cluster can idle for hundreds of microseconds before it comes back before it can restart processing. And that's a real problem, right? And I don't think anybody's ready for that. And NVIDIA maybe just luckily is in the right place at the right time.
Well, I think Broadcom would argue that its Jericho AI chip is sort of purpose-built to do this optimized Ethernet, and they're adding capabilities like what you find in that Bluefield DPU, the SuperNIC from NVIDIA, things like, congestion control, slicing up frames into cells and then marking them so that they can arrive in the right order, that kind of thing. The question is, do you want to do that in the ASIC or do you want to do it out at the edge?
I think you want to do it in both. Is probably the final answer, but it matters more in the DPU where you need to do other things anyway. You need the DPU to do acceleration of the networking. You need the DPU to do accelerated storage I/O. You need it to do RDMA. So the data needs to come out of the GPU across the internal bus into the DPU and then onto the Ethernet fabric It shouldn't go via the CPU. If you're doing it that way, I doubt you'll be able to get a value proposition out of your servers.
Right. And I will also note that we mentioned the Ultra Ethernet Consortium. Nvidia is not a part of that consortium, but folks like Broadcom, Arista, and others, Marvell, are. So we can see how this divide is lining up.
I think they joined this week.
Did they?
So,
okay.
I didn't really put it in because, who cares who joins the DriveNets also joined the Ultra Ethernet Consortium. I think everybody's going to be there, Drew. It's not really, a big deal. Everybody's going to join it because there's nothing to stop them.
That's true.
Whether anything will come out of it until 2025, 2026, well, maybe. I feel it'll take a long time. Look at the IEEE. It takes a decade for a new Ethernet standard to emerge. How do you think this is going to work?
Well, I think there's a lot of vendors in the Ultra Ethernet Consortium who are interested in getting it to work as fast as possible. We'll see if they can align all of the various incentives they have to pull something out. But the reason they started Ultra Ethernet and not gone to an existing body is because they wanted to move fast. So yeah, we'll see what happens. And it's interesting that Nvidia is in there now. I'm gonna
the pre-standard standards body is the Ultra Ethernet, just like the Ethernet. Right. The other ones. There's lots of them for Ethernet. There's dozens of pre-Ethernet standards bodies that work things out and then take it into the standards body. That's why it takes a decade. So,
a quick break to tell you about our sponsor, Doit. Doit can help you with your cloud challenges. Maybe you want to maximize your cloud use while controlling costs, or perhaps the issue is balancing resource utilization while delivering agile IT. Maybe you just can't get good support from your cloud partners. Doit can help. They're an award-winning strategic partner of Google Cloud and AWS. They work with over 3,000 customers to save them time and money. Doit combines intelligent software with expert consultancy and unlimited support to deliver cloud at peak efficiency with ease. The Doit team knows multi-cloud, cloud analytics, optimization, governance, Kubernetes, AI, and more. Work with Doit to optimize your cloud investment so you can stay focused on business growth. You can find out more at doit.com. That's DOIT.com. And we thank Doit for being a sponsor. All right, a little bit of space networking. China has successfully launched a new satellite to test the creation of a space-based internet service similar to Starlink. Now, the Register is reporting that the satellite is one of a handful of test devices that could eventually lead to a so-called mega constellation of satellites to provide broadband internet service. Back in April of this year, Space News reported that China plans to put approximately 13,000 satellites into orbit as part of this network.
So nothing here should surprise anybody who's sort of following along here. The thing about SpaceX and Starlink is that anyone can copy what they've done. You need a lot of money, some smart people, and a willingness to make mistakes. And the money means that you can make mistakes and keep trying, all right?
Yep.
And all credit to SpaceX, who've taken some huge risks on using new manufacturing ideas, new designs for their rockets, and radical ideas in the way that to come up with a reusable launch vehicle. And SpaceX has gone on to prove that modern rocketry is all about reusable launch vehicles and operating at scale. Don't just build one rocket at a time, have a whole factory that churns them out at 3 a week sort of thing, right? Which is quite a change in the way that we approach rocketry, and it's going to upend the industry, has already upended the industry. But the point here is that any government could choose to spend its money to copy them. And a few billionaires, there's a few billionaires around the world who've probably got enough money to do it as well. And it might not be profitable, but then neither is SpaceX or Starlink, to be fair. So depending on who you listen to, neither SpaceX or Starlink is profitable. They're still burning cash.
Right.
Although Starlink may no longer be quite burning just as much cash as it was before. It does have a revenue stream, so we'll see. So I would say that Chinese government has military considerations, of course, to build its own communications network that would be used by its military, but also it needs one in China because I don't believe that China would want to take Starlink. They would see that as probably not acceptable to the people of China who they care for. So, and there are plenty of other microsatellite networks with licenses from other countries. So, for example, OneWeb is the UK government bought them out of receivership and now partner with the EU. And they're now launching test satellites, and they have plans to launch 10,000 satellites into a network. Blue Origin, with its Kuiper satellite network, continues, although they're struggling to get too much up. At the moment, they're lifting on SpaceX rockets to get some testing done. So really, this shouldn't be a surprise that China launches these satellites with planning to build out its own network, because militarily, they're just so successful. You shoot down one of these satellites, Drew, and what?
Because we get 12,999 to go. Yeah,
that's right. Whereas today they have satellite killer rockets because up until now they've been lifting 20-ton rockets into space and putting them in geostationary orbits where they never move and they're really easy to hit. You know what I mean?
Yes.
Well, not easy. I mean, you've got to send a rocket into space to do it. But point is, and you take it out and then the whole satellite network is there. Well, this is going to be the way of the future. And ultimately, it's not a unique thing. So it shouldn't be any surprise that China is doing this if you've been following along.
Yeah, I think obviously, China is a huge country. Getting internet service to its entire country, to its entire population, terrestrially is difficult. So, of course, satellite broadband makes sense. And the fact we know China wants to control internet access and what happens on the internet. So building its own satellite network would be the way to do this. I wouldn't be surprised if there are also, military and surveillance and other communications applications that could ride alongside, providing internet service. So not a surprise.
I think it's great because there's more bandwidth left for us. I think it's, if you're using Starlink, you're probably relieved.
Yeah, that's right. 1 billion people won't be crowding out my Netflix stream if I'm on Starlink. Yes.
That's exactly right. So yeah, feature, not a bug.
Yeah.
Perhaps unless you're in the military, maybe more of a concern.
Well, sticking with space news and big countries with lots of population and difficulty providing them internet access, the Indian government has granted authorization for EutelSat OneWeb to provide satellite-based broadband customers in India. More than 600 satellites are already in place to provide that service. The final hurdle will be government allocation of spectrum for the service. According to the register, EutelSat OneWeb beat out bids from Starlink, Kuiper, and others to get the job in India.
Yeah, so governments issue spectrum licenses in every country of the world. That's why Starlink can only operate in countries where the government has given them permission to use a spectrum and granted permission for Starlink to act as a carrier. Now, that is a global standard that has been around for 200 years or more. And so India decided to turn it into a commercial exercise, and EutelSat, which is the European and UK partnership they bought OneWeb out of receivership and then continued to invest in it to grow it. So it is the European version of Starlink, if you want to think of it like that. Largely government funded, I want to say, although a substantial part of it is a private and for-profit business. I also think there might be some political considerations here. India will benefit from having widespread low-cost internet across the country, of course, but they can afford to wait. There's no need to rush into this. I think that Starlink has, a less than excellent reputation recently. We saw the problems in Ukraine. Who wants to be beholden to to Elon Musk, who can be unstable? The
capricious decisions of a CEO, yes.
Yes, and so maybe doing a partnership with the European government at a political level, because this is obviously a very political decision, is suitable. And of course, India does have a reputation for doing things differently. So, for example, much of India's military is well supplied with Russian equipment. They've been choosing to buy Russian military hardware for quite a few years now. And that was an unusual decision, but it was also seen as a very cost-effective and smart choice at a certain point in time. So, and of course, British and European politics may have influenced the decision with India. So we'll see. I think it's great for OneWeb to get a win, and to get it in a country like India is probably really a fillip for them in the short term to give them a motivation to get their satellites up.
Yeah, it's great to see competition. So that's my big takeaway. Good competition in space networking is what we need. All right, one last Nvidia story before we wrap. The company announced results for the third quarter of its fiscal year 2024. The company posted revenues of just over $18 billion, up 206% from this time last year. Net income was $9.2 billion. That is up 1,259% year over year. I guess you could say it was a good quarter.
So if you want to know why there's so much hype in AI and why CEOs are all rabbiting about it, this is probably the reason, Drew.
Well, I guess I'd actually reverse it, that all the hype around AI is making them run out and buy GPUs, which is great for NVIDIA.
Yeah, no, that's what really happens. But you can bet there's a lot of CEOs looking at their bonus packages saying, he got what? He made a 1,300% increase. It's just bonkers. Like, it's just, there's not a CEO in the world who reads this and goes like, maybe I can get some AI and get some 100% growth. Of course they can't, but there you go. Yeah. So I'm not going to bother talking about the other business units in NVIDIA. There is other ones, gaming and so forth, but none of those really grew much in the last few years. It's all data center. Mm-hmm. The data center business went from $3.6 billion a quarter a year ago. That is Q4 last year, mm-hmm. and it's now 14.5 billion in this quarter. The last quarter was 10.3 billion, 14 point. No, it's just
stunning.
Bonkers.
Stunning,
it's just amazing. And not only that, they increased their gross margin by 16%. So at the same time, not only are they selling more, they're increasing their gross margin, and they're also increasing their net income. So after operating taxes and all operating expenses, the operating expenses to make 14.5, get this is just crazy. Operating expenses only went up by 16% year over year.
Wow.
But they made 14.5. So operating expenses up 16%. Net income up 1,259%. Revenue up year over year. These are all year over year numbers, up 200% overall. So they've gone from, just amazing. That's why they're now valued as $1 trillion company, because the cost base is so low. Once it's designed, they get it manufactured at TSMC, ship it out to the world. The more that they can sell, it's all just raw profit margin.
Yep.
And it's, just amazing what they've been able to do. Right place, right time, and genuinely innovative, because they did spend years developing their GPUs, writing software on top of it.
Yeah.
So if you want to understand why there's so much hype around this, go and have a look at their financial results. There's a link in the show notes, and just look at this. Just imagine getting a pay rise where you increased your pay by 12x in 1 year.
Yep.
And what that would do for your life.
Yeah. Yeah, just to round this out, the gaming revenues were $2.86 billion, which is up 81% from last year, which in any other normal company would be like, great, we went up 81%. But then you look at the data, overall revenues were up 206%. You're like, wow, 81% is not great. Fantastic, stunning results from Nvidia. I wonder, if AI is a gold rush, Nvidia is in the enviable position of selling shovels. But at some point, I think this has to cool off, doesn't it?
I think so. So, for example, this week, Microsoft announced that it was developing its own AI chipset, and it has a name, and it's announcing that it will soon have it available for customers. Of course, Google's got their own. AWS is quite a bit behind. I think by most of the articles I've read, most people are sort of saying that AWS is coming from a long way behind in the AI. They've been caught very flat-footed and not ready for it when it sort of arrived. But they're coming back. They'll come back quickly enough. They can afford to waste money getting that fixed, but they'll have their own processor. So NVIDIA's, competitive edge may be short-lived. Again, there's nothing the thing that stops companies from going into NVIDIA hardware is the fact that, stops companies from leaving NVIDIA hardware is, of course, the software that they run on top. So the more of NVIDIA's APIs and softwares and libraries that you use, or the more of NVIDIA's foundation models that you use, we talked about those last week, the harder it is to get away from their GPUs. And once you can't get away from their GPUs, you're locked into their ecosystem. Right. But that doesn't mean that there's not other people playing in the ecosystem taking away bites of it.
Yes.
AMD, of course, Intel's got its GPUs. There's a number of supercomputers that are quite successful with Intel GPUs. You can't count Intel out, although it's hard to imagine that they can be, displacing NVIDIA anytime soon. So we'll see. But hard to imagine that NVIDIA is going to be, smaller this time next year, Drew. Maybe they don't grow at maybe they don't grow at 1,000% again, but it stabilizes here.
Still, NVIDIA's got a big head start, but companies seeing $14 billion in one quarter are going to be looking at that and saying there's market share for us to take. So, yeah, it's a rocket ride for NVIDIA. I guess it's probably cigars all around in the boardroom, and we'll see how long it lasts. And
just to point out that, yes, there's a lot of news this week is NVIDIA. There wasn't a lot of other news because it is Thanksgiving over the weekend, and we're recording this on Monday after Thanksgiving to having had a couple of days off. So apologies for all the news being not necessarily totally focused on networking, but there was only a limited number of things to talk about.
Yeah, we didn't intend to do an all NVIDIA or mostly NVIDIA show, but there it is. All right, that wraps up the news portion of the show. Thanks for listening. Please stay tuned for our Tech Bytes conversation where we're talking with Nokia about enhanced techniques to combat DDoS attacks. It's coming right up. Distributed denial of service attacks, or DDoS, have plagued the internet for decades, and attackers are finding new ways to take advantage of higher levels of bandwidth and the ever-growing number of network-connected devices. So today on the Tech Bytes, sponsored by Nokia, we're going to talk about what's brewing on the DDoS front and how Nokia's Deep Field is bringing new analytics techniques to the fight. Our guest is Craig Labovitz. He is head of technology for Nokia Deep Field. Craig, welcome to the podcast. So as I mentioned, DDoS has been an issue for ages, but are you seeing new techniques or tactics that attackers are putting into play?
Yeah, absolutely. When we started 25 years ago doing DDoS, most DDoS came from a relatively small number of Eastern European and Asian data centers where the traffic was spoofed. What's largely changed is both the technology to solve the problem, the market problem, and of course, the motive and who's doing the DDoS. So 25 years ago, most DDoS detection and mitigation was designed around spoofed. The really dramatic change today is a significant majority of DDoS is not spoofed. It's not coming from small number of hosting and data centers. It's coming from compromised IoT devices in every network in Europe, Asia, US. It's coming from just millions of compromised DVRs, NVRs, video systems living in every enterprise, living in every gas station, every small law office, all have these cameras and other devices. And
I read somewhere today, Craig, that there's this lawsuit started against Amazon and Google for selling Android TV sticks, like Fire type things, and they ship with malware. Known to be shipping with malware. They've been reported and people have done nothing. And they're shipping thousands of them every week. That is just a significant change in the way products work.
Yeah. And, the problem, if you look at any of the graphs of the number of compromises, particularly of IoT devices per year, it's on an exponential tear. And it's every type of device. This morning I was working on a customer issue where they were being attacked by earthquake sensors across the U.S. that all had been compromised. So, while it largely is a problem of different types of CP routers and videos, we see parking meters. I don't see any refrigerators compromised, but, basically every other type of device.
Just wait 5 minutes, I guess. And I think the issue here is that these are devices that are supposed to be on the network. They have a legitimate reason to be on the network. So it's not a question of trying to identify that they're spoofed. It's just the fact that it's about a numbers game now.
Yeah, and the traffic otherwise is legitimate. These aren't spoofed packets. These are packets coming from real embedded Linux stacks. So it otherwise looks exactly like. There's no secret bit in the payload to distinguish. And quite a bit of this traffic, by the way, is using encryption. So it's very difficult using historical DDoS techniques to be able to differentiate between the good and the bad of the traffic.
What about the change in the consumer with now that they're moving to symmetric bandwidth? So we're seeing customers are having 100 megs to the house with a 20 meg up, or gigabit symmetric, like gigabit up, gigabit down. That's got to be changing the numbers as well.
Yeah, that's really the other really massive market shift. For years and years, most homes were 10 meg up, 100 meg, 500 meg down, but very, very with DOCSIS. With DSL, very limited upstream bandwidth. When you look at the press releases coming out of Europe, Asia, and the US, every major provider has announced gig or 10 gig, even larger symmetric plans. And what this does is for 25 years, compromised devices in the home and the enterprise were an annoyance because they were all 10 meg up.
That's right.
When they go to 1 gig or 10 gig, it is a very different threat proposition that many of our customers are facing.
And I think the edge networks are bigger too. So because they're now delivering that, the actual, once upon a time, a broadband service might have only had a 2 meg uplink or a 10 meg uplink, and now they have multiple gigabit, like they have hundreds of gigabits going back to the core of the network. That's a transition too.
Yeah, and it's a very different network. And, we're moving to just a number of devices that are being connected. So, as we move to fixed mobile, just these massive rollouts where it's increasingly economically feasible to have just many more devices directly exposed to the internet.
And what about the entities of organizations using DDoS as a tool or a weapon? It's often criminal gangs, but that's changing too, right?
Yeah. So for years and years, providers and vendors like to tell stories about state actors and larger criminal organizations. But for most of the past 25 years, DDoS, at least to me, always seemed more of a sort of mom and pop, 5-10 members of a criminal gang that managed to find some black market hosting, allowed them to spoof, or maybe a handful of botnets. Particularly starting with the outbreak of hostilities in Europe last year, there are, really, I think, compelling signs that state-affiliated, state-sponsored actors got involved. And really, for the first time, things vendors had warned about for years likely became true. So we saw a really significant shift from botnets that numbered in the few thousands, which was typical, to botnets that we had never seen before, brought out just at the start of the conflict, numbering in the hundreds of thousands. So, really dramatic shift in the scale of the available resources, the size of the attacks and the complexity of the attacks. really, again, tied to the start of the conflict.
What about RPKI and other tools that we've done with routing from the telcos to secure the BGP routing? Have they had an impact, or is this really just, yes, it had an impact, but it's even worse in its own way?
So I think all of the BGPsec, DNSSEC, RPKI, all these techniques to limit the amount of spoofing have been meaningful and important and have had an effect on decreasing the amount of spoofed DDoS we saw coming from a small number of hosting providers traditionally. Mm-hmm. The challenge is today, the traffic isn't spoofed. It is coming from every enterprise, from, every gas station, convenience store, millions of consumers with a compromised IoT. Okay. And by the way, you don't need a large percentage of IoT devices to be compromised if they are on an exponential curve. Today, some folks are predicting we're now in the 10 billion number of IoT devices and growing. Yeah. So it really is an issue of just the scale of the IoT rollout that we're seeing, and no decrease in the quality of the code and the, embedded operating systems being installed on these.
Okay, so I think that's a good summary of the problem, but we're here to talk about Nokia Deepfield and what you're doing. Can you give us a sense of, I guess, maybe some quick background on Deepfield to set the stage, and then, new techniques that you're bringing into the fight against DDoS?
Sure. Yeah, Deepfield joined Nokia about 2018. We started out as a startup. And the focus of Deepfield really has been the idea that the routers from Nokia have become increasingly capable to actually embed DDoS detection and security directly in the routers, i.e. not the need for lots of different hardware in the network. Uh-huh. So building security into the network.
So this means instead of having a bunch of specific DDoS filtering hardware, I can actually do some of that filtering in the router itself?
Yeah, so the routers have become capable to embed the filters detection directly in the silicon without the need for all these other third-party devices in the network.
So how does that work in practice? Is that you collect flows sampling? Do you do DPI? What are the technologies you're deploying in that today?
Sure. So Deepfield does two things. One is it leverages IPFix standard IETF protocols. We also leverage Nokia specific protocols where we can get DPI and packet samples. When Deepfield ingests these samples from the network, we also have the ability to directly program the silicon on the FP45 Nokia silicon chipsets to block the DDoS directly on the router.
Right. So it's direct. So you've got silicon support here, which gives you scale, able to get to hundreds of megabits, hundreds of gigabits, 100 terabits even, I guess.
Multi-tera, 2.8 tera.
So how do you address concerns then if I'm a service provider and these routers are, essentially my business model, that I'm also using them for DDoS filtering, that DDoS capability isn't going to take away from their capability to move packets to customers?
Yeah, traditionally on other vendors, adding filters and ACLs has always impacted forwarding performance. One of the key design points for Nokia has been that ACLs policies have no impact on the forwarding performance. So really, I think a key difference in the technology stack.
Okay, and again, custom silicon that you think that gives you that capability?
Yeah, it's custom silicon.
The key here is that the routers that do WAN backbones for the biggest telcos in the world are also DPI protection services, because the silicon supports the features, and all you have to do, get some flow records into Deepfield, get some packet samples and deep packet inspection derived from that, and then all of a sudden you can start blocking at scale. You can do DDoS prevention at scale.
Yeah, exactly. And, if DDoS is on an exponential curve as it's continued in terms of scale, size of the attacks, and you are trying to fight it using traditional, third-party appliances and just stacking them as fast as you can, you've got a scale problem.
But it's a cost problem as well, because the more DDoS appliances you get, the more cost you've got, the more power you consume, the more space you use, the more maintenance contracts, and more asset management. So being able to do this in the router is a key advantage.
Oh, no, exactly. As the old NASA phrase, with enough thrust, anything flies. So with enough hardware in the network, that's what the attempt folks are trying to do today. But really, the only economic thing that is scaling with the size of the attacks and the size of the network are the routers themselves. Yep. No other third-party FPGAs have this scaling factor.
And you're also avoiding DDoS cleaning services where you actually divert the traffic off your network to someone else or into a a stack of appliances, because that's, and those, as you say, those solutions don't scale. Or maybe are they still necessary and you can complementary to those?
So, I think there's many different sort of scenarios, but in general, deploying and diverting traffic is complicated, involved, and expensive. It is far more efficient. It is far faster in terms of latency and the time to defense if you can just mitigate the first time a network sees the bad traffic.
At the edge, yeah.
At the edge.
So we talked about increased bandwidth, increased number of devices on the network. AI is also now on the horizon, or at least maybe is it even here? How does AI play a role in what Nokia is doing?
So AI is a key part of our business strategy. In the past, typically folks were doing DPI, trying to find just a bad bit individual packet. Mm-hmm. Today, with DDoS, there is no bad bit individual packet. Instead, it is understanding across all of these compromised devices. So, for example, seeing traffic from just one camera on the network may not be unusual, but 10,000 all at the same time is signs, or almost always signs, of an attack. So it really is being able to reason about more than just payload, being able to reason about topology, about the different type of devices sending traffic, and about the typical network patterns as well, all of which goes into a large sort of machine learning engine to provide very granular, very accurate DDoS detection and mitigation.
So AI is a better way to fingerprint DDoS or to identify DDoS and then turn it into a rule that can get down into the silicon at the edge of the carrier core.
Yeah, and it's reasoning about larger data sets. So it's not just reasoning about individual packets, but what Nokia has done is reasoning about the entirety of a network and the entirety of internet devices. So we do quite a bit. We do crawling of the internet. We do discovery, reputation. We track every IP on the internet. All goes into this engine to build very accurate, very fast detection mitigation rules.
So it's not like the old day where it was basically a bunch of ACLs that were being updated on a regular basis. It's a much more sophisticated approach.
Correct. The old days when you just looked for a particular pattern in the DPI are gone. The traffic is encrypted. The traffic no longer has that bad DPI pattern. It's coming from real devices. So different techniques are required.
And it's bigger. It didn't get, and it's just more of it as well. I still can't get over the scale of it. We're talking terabit class DDoS attacks in the last few months. So it's hard to imagine.
I understand Deepfield has a program called Secure Genome. Can you tell us about that and how it applies to DDoS protection?
Yeah, Secure Genome is part of the program. It's just the program I was describing. It's a machine learning program where we ingest crawling data from every reachable v4, v6 address. We fingerprint every device. We track patterns in those devices if we've seen them used in other attacks before. And all of that data goes into real-time detection mitigation within our customer networks. So very, very large corpus of information about the entire internet.
Well, let's switch to talking a little bit about products. I know we talked about ASICs and how the features are already in the routers, but I think you've actually been bringing new hardware into the Deepfield DDoS portfolio.
Yeah, so Nokia has, as we discussed previously, we have the FP4, FP5, custom Nokia ASICs that we've been able to leverage and continue working with our hardware team partners in Nokia to develop features directly on the router. More recently, for edge networks and data centers, Nokia just a few months ago announced our FBCX for other parts of the network that will have similar capabilities. But for Nokia, the general strategy is, instead of an afterthought, security is part and parcel and built into the network from day one.
All right, let's talk a little bit about the products, because if people want to implement this service, there's still some hardware. Recently, you've been extending the DDoS portfolio, the Deepfield DDoS portfolio, with some new hardware. Let's talk about that.
Yeah, so in addition to FP4, FP5 capabilities on the edge routers, we now have what we call the Defender Mitigation System, or DMS, and that is a one-to-one replacement for existing hardware scrubbers. But instead of using FPGA, it uses the existing FP4, FP5 chipsets modified with special software in a standalone platform. So provides much more flexible deployment options for deployments where they do want to have scrubbers and they do want to continue off-ramping, or they don't have Nokia routers on their edge.
Right. And that's key, because a lot of telcos may not be using Nokia. I mean, lots of them do, but some don't. This would allow them to put that in. And then, as you say, you can do the diversion where you divert the DDoS traffic into a scrub or a cleaning mode, send it. The thing that catches me about this is the capacity. 2.8 terabits per second is a lot for a DDoS scrubber.
It is. And again, a lot of this comes down to cost. So one of the design goals was the cost price point for DDoS mitigation. But the next largest are 400 gig, some devices getting up to 8. But this is significantly larger than anything else on the market today for a much more efficient cost price point for data center off-ramp DDoS mitigation.
So it's clear Nokia is putting a lot of investment into DDoS protection, but it's not something that one company can handle by itself. Are there more collective efforts across the industry to take on DDoS?
So Nokia is working with our partners. We recently announced something we call GDTA, or the Global DDoS Threat Alliance, for our customers and other ISPs to be able to share information about attacks. And again, it really is, I think, two issues. One, it's a collective fight against these attacks. And I think the second major is we are working with more customers on their own networks. That typically providers were only concerned about attacks coming into their networks. Increasingly, we are working with providers that are working to mitigate the attack traffic coming out of their networks and attacking other providers from compromised bot and IoT devices. So both of those were quite enthusiastic to be able to take a broad attack against DDoS.
That would give you more accurate detection and protection, because the more information you've got, in theory, the better your AI and machine learning algorithms to recognize it, and the more number of sources. But what I also like is you're opting in. You're not saying to customers, we're going to take your data. You can opt out if you don't want us to, but there's a thing there, right? There's an approach here to say, please opt into this.
Yeah, exactly. It is opt-in, and it does provide both local visibility for providers to be able to see attacks before they hit their network. And again, it is very useful data as we try to understand the global DDoS trends and make sure the machine learning and algorithms are several steps ahead.
And this is something that's happened elsewhere in the security landscape. We have various cyber threat forums where they agree to share intelligence about threats, and they trade signatures and information about new attacks that are happening. So you can get these into the feeds, and there's this public data, and everybody gets protected. It's not sort of hoarding the information for yourself.
Yeah, exactly. That's the same goal. So, it really is very specific types of information we need. It's not the payload. We don't need user identifying, but it really is understanding the different types of devices, the different types of networks, the different parts of the world, understanding these patterns in DDoS that help us stay several steps ahead.
Well, we are out of time. Craig, thank you for being here. I want to let folks know if they're interested in getting more details about Deep Field Defender, the mitigation system, the Global DDoS Threat Alliance, and other material from Nokia. We'll have all of those links in the show notes that accompany this podcast. Thank you, Craig, for being here. And thank you, Nokia, for being a sponsor. And as always, thank you, the listener, for joining us. If you like this episode, you can find this and many more fine, free technical podcasts and our community blog. It's all at packetpushers.net. You can follow us online at Packet Pushers, hear us on Spotify, and if you would, rate us on Apple Podcasts. And last but not least, remember that too much networking would never be enough.